Jai Hind, myself Nehaga, and this is a complex lecture on the topic communication system and modulation. This topic has been taken from the subject fundamentals of electronics engineering, and this subject is currently being run in the syllabus of AKTU. So basically, communication system. Why we require any communication system? This system is basically used for transmitting any kind of information or message from one place to another. This information may be in the form of any text message, picture, song, music, any kind of message can be transmitted with the help of the communication system. So basically, this system consists of different blocks like information source, input transducer, transmitter, channel, receiver, output transducer, and destination. So here, first block, that is the information source, is basically the message or the information that we want to transmit. And this message or information, it may be in the form of message, sound, picture, words, or light. So basically, like my voice is also a signal that we want to transmit. But the voice audio signals lie in the range of 20 hertz to 20 kilohertz. So these are very low frequency signals. So we can not directly transmit this signal from one place to another at long distance, like from this place to Delhi or to Bombay. So this will the signal get attenuate as the distance increases. So so information is basically the message that we want to transmit. After that, input transducer is there. So transducer converts one form of energy into another form of energy. Like microphone, if I am using microphone, that microphone will convert my voice into the electrical signals. So this microphone acts as a transducer. It converts the sound energy into electrical energy. Like photodiode is also a transducer. It converts the light energy into electrical energy. LED is also a transducer. It converts the electrical energy into light energy. So one form of energy is converted to another form of energy. That is, the device is called the transducer. And this is required because if we convert any message into electrical form, so that electrical signal can be easily transmitted to another place. And the processing with the electrical signals are also very easy. We can amplify the electrical signal, we can filter out the electrical signals, we can attenuate the electrical signals. So electrical signals can be processed easily. So generally in process, we convert any message in form of sound, light, or picture in form of electrical signal for transmitting purpose. So here transmitter is there. Next block is transmitter. So transmitter is basically, it contains all the devices that makes the transmitted signal in a suitable form. They converts that signal into a suitable form that can be transmitted over the channel. So transmitter basically, it contains the modulator. So modulator is generally used for transmitting the low frequency signal. Low frequency signal cannot be transmitted to long distances. So these signals are sent using the carrier waves, and carrier waves are the high frequency waves. So in modulation process, the properties of the carrier wave is varied in accordance with the instantaneous value of the modulating signal. So modulators are used with the transmitter to send a low frequency signal. Now this channel, here there is an antenna in the transmitter, and this antenna transmitted the message signal. And channel may be wired, or it may be wired, or it may be wireless. Wired means like we connect the transmitter and the receiver. Our transmitter is in Delhi and receiver is in Bombay. So we connect the transmitter and receiver with the help of the coaxial cables. So coaxial cables. So if the connection is done with the help of the wire, then it is called a wired communication. And if it is done without the help of wire, like through the air, through the water, or through vacuum, then it is called the wireless communication. So wired communication, or optical fiber communication is there, in which the information is transmitted in form of light pulses through the optical fibers. So in case of the optical fiber communication, channels are the optical fiber. And in case of, if we want to transmit the electrical signal, then we will use the coaxial cables as a channel. And like telephone lines are also used as a wired channel. And in wireless satellite communication, mobile communication, all these are the examples of the wireless communication in which the signals are transmitted through the satellites or through the repeaters on the grounds. So, and if we transmit any signal through the channel, there may be a chances that some noise may introduce in the signal, and this noise may distort the signal also. So, like if we transmit the signal through the air, so in that case, thunderstorms and due to the clouds, this signal may be distorted. And this is the at the receiver side. Like if we transmit the signal from Delhi to Bombay, so at Bombay there will be a receiver, and here there will be an antenna, and this antenna will receive the signal that has been transmitted through the transmitter, through the channel. And receiver side, we have an output transducer, and this output transducer converts the signal into another form of energy. Like microphone converts the sound signal into electrical energy, and that electrical signal can be transmitted to another place, and at the destination, output transducer will be there, that is the loudspeaker, and that loudspeaker will convert the electrical signal again into the sound signal, and we can hear the voice also. After that, and here the message has been transmitted from this place, and here that message has been received at the destination. So this is the block diagram of the communication system. Means we can transmit any kind of message from to another place by using this system. Now this communication system may be wired, it may be wireless, it may be optical fiber communication system, it may be wireless communication system, it may be mobile communication system. Any kind of communication system may be there, depending upon the type of the channel we are using. And in the communication system, we have seen our term modulation. So basically, modulation is generally used to transmit the low frequency signals, because low frequency signals have low strength, low energy level, so they cannot travel the long distances. So generally, if we want to travel one place to another, we use some carrier like bus, car, train, anything, and then we can move from one place to another at long distances. So similarly, modulating signal is basically our message signal. This is our message signal that we want to transmit, and this signal, it requires a high frequency signal that is used as a carrier to be transmitted from one place to another. So basically, like this is our message signal, and this is our high frequency carrier. This one is the carrier, and this is the modulating signal. Modulating signal is generally in the range of 20 Hz to 20 kilohertz if we are using the audio frequency signal. Now, why we require this modulation? So first reason I have told you already, that it increases the range of communication. Low frequency signal can be transmitted to long distances, and after that reduces the size of antenna. It reduces the size of antenna, avoid mixing of signal, allows multiplexing of signals, adjustment in the bandwidth, and improves quality of reception. So basically, reduces the size of antenna. So if we use the low frequency signal for transmitting purpose, we can see if we are using the 10 kilohertz, then the height of the antenna will be, the antenna having the minimum height is lambda by 4. So if we using the frequency of the signal that we want to transmit 10 kilohertz, then the height of the antenna will be 7.5 kilometer. So it will be very large amount that is not possible to design such type of antenna. So if we are using the 10 megahertz frequency, means high frequency signals, in that case the minimum antenna height will be 75 meters. So that's why we use the high frequency signals as a carrier. If we use the low frequency signals, then the antenna height will be required very high, that is 7.5 kilometers. And with high frequency, the antenna height will be reduced. Avoid mixing of signal. Like if we want to transmit the signals, like 3 signals I want to transmit 20 hertz, 20 kilohertz and 30 kilohertz and 40 kilohertz. These three signals, massive signals, I want to transmit over the channel, and we can see these signals are very nearby. Only 10 kilohertz difference is there between these three signals. And for this signal, I am using the carrier signal of 100 kilohertz. And for this, I am using the signal of 200 kilohertz. And for this, I am using the carrier signal of 300 kilohertz. Means if I am passing the three massive signals of frequency, nearby frequency through the channel, so these three signals may interfere with each other because the frequency difference is very low. But if I modulate all these three signals with the three different carrier waves, like 20 kilohertz signal is modulated with the help of 100 kilohertz carrier wave, and this signal is modulated with a 200 kilohertz wave, and 40 kilohertz signal is modulated with a 300 kilohertz wave. So the bandwidth, the range of the frequencies that will be transmitted by using this 100 kilohertz carrier, it will be 80 kilohertz to 120 kilohertz. After that, it will be 170 kilohertz to 230 kilohertz, and it will be 260 kilohertz to 340 kilohertz. So we can see now the range of the frequency has become 80 to 120 for 20 kilohertz signal, and for 30 kilohertz signal it has become 170 kilohertz to 230 kilohertz, and 40 kilohertz signal it has become 260 kilohertz to 340 kilohertz signal. So we have now, if these three signals will pass through the channel, they have different frequency range. So there will be less chances of mixing of signals. There will be less chances of interference of all these signals. These signals may interfere with each other if we pass channels, but after modulation, these frequencies become this, and there will be less chances of interfering of the signals. Increases the range of the communication. Low frequency signal can be transmitted to long distances. Allows multiplexing of signal. Multiplexing means we can pass a number of the signals or message signal through a same channel simultaneously. This process is called a multiplexing. And we have seen in the last slide that we have taken three different signals, and we have modulated all these signals with the different carrier waves, and all of these signals can be passed simultaneously through the channel. There will be no chances of interference. So with the help of this, we can do the multiplexing also. Normally what we do, we use the single channel, and we pass the one signal through the channel, then another signal is passed, then third signal is passed. So we are doing this one by one. But if we are passing all the signals simultaneously through the channel, then it will be called as a multiplexing. So multiplexing is possible with the help of the modulation process. And after that, improves the quality of the reception. So frequency modulation, there will by using frequency modulation and digital modulation, that is PCM, effect of noise is reduced to a great extent. This improves the quality of reception. So frequency modulation provides the best result. The received signal will be distortion free in case of the frequency modulation. Now these are the different types of modulation. That is your continuous wave modulation and pulse modulation. So in continuous wave modulation, carrier wave is sine wave. Carrier wave is sine wave. And in pulse modulation, carrier wave is in the form of pulses. After that, we can see this continuous wave modulation. It is again divided into two parts, like in amplitude modulation and angle modulation. Angle modulation is again divided as a frequency modulation and phase modulation. So amplitude modulation, basically what is a modulation also? Modulation is a process in which the properties of the carrier wave is varied in accordance with the instantaneous value of the modulating signal. Like this signal is our modulating signal. This is the low frequency signal, modulating signal, or the message signal that we want to transmit. And we are using this type of carrier wave, high frequency wave, for transmitting this signal. So the properties in modulation process, the properties of the carrier wave is changed according to the instantaneous value of the modulating signal. Properties are amplitude, phase, and frequency. So these are the three properties: amplitude, phase, and frequency. So if the amplitude of the carrier wave is changed according to the instantaneous value means at this instant its value is this, at this instant its value is this, at this instant is this value is this. So at different instants the value of the massive signal is continuously changing. So according to the instantaneous value, if the amplitude of the carrier wave is changed, then it is called the amplitude modulation. And if the frequency of the carrier wave is changed, then it is called the frequency modulation. And if the phase of the carrier wave is changed according to the instantaneous value of the modulating signal, then it is called the frequency modulation. So all these frequency modulation, phase modulation, and amplitude modulation are defined by this. And in pulse modulation, carrier wave is in the form of pulses, like in this. This is the pulses. So it is again digital modulation and analog modulation. In analog modulation, pulse PAM is pulse amplitude modulation. Means the amplitude of the pulses. This amplitude of the pulses are changed in accordance with the instantaneous value of the massive signal. In PWM pulse width modulation, width of the pulses are changed according to the instantaneous value of the modulating signal. In PPM, position of the pulses get changed in accordance with the instantaneous value of the modulating signal. In pulse code modulation, we obtain a digital output in here. Digital codes are there, and it includes the process like quantization and coding. All these things are there in case of the pulse code modulation. But after that is amplitude modulation. So in amplitude modulation, we can see here this is our modulating signal or the massive signal that we want to transmit. Is a very low frequency signal. After that, this is the carrier wave signal, and here we can see this amplitude modulated wave. Here we can see the frequency of the amplitude modulated wave will be same as the frequency of the carrier wave, but its amplitude is changed. Amplitude is changed according to the instantaneous value of this modulating signal. So here we can see in this part there is no massive signal. So here we are getting the same carrier wave. Here all no modulation is there, but here massive signal is here. So we can see this type of envelope is there. So this output is the amplitude modulated wave. This amplitude, we can see this part is equal to the VC, amplitude of the carrier wave, and this part is the this wave is the massive signal. So here we can see the amplitude of the AM wave can be varied accordance with the instantaneous value of the modulating signal. So this amplitude modulated wave is generally transmitted with the help of transmitter in the using antenna. So this slide depicts the frequency modulation. So this is the modulating signal or the massive signal. This is the carrier signal, and we can see here the amplitude is more. So here the frequency of the signal is very high. Here the frequency of the signal is low. Again frequency is high. Again frequency is low. So frequency FM. This is the frequency modulated signal. The previous one was the amplitude modulated signal, and this one is the frequency modulated signal. And here the frequency of the signal is continuously changing according to the instantaneous value of this massive signal. After that, this slide depicts this is analog massive signal, and the carrier wave is in the form of pulses. That was in the pulse code modulation that I discussed in the last slide. And this is the pulse amplitude modulation. We can see the amplitude of the pulses are in accordance with the modulating signal, and here the width of the pulses are changed according to the modulating signal, and here the position of the pulses has been changed. And in PCM we are receiving the digital output. Digital encoding process is there in the case of the PCM. After that, modulation index. So modulation index depicts the degree of modulation, level of modulation or degree of modulation, and it is defined by the M is equal to Vm by Vc. Vm is the amplitude of the message signal and Vc is the amplitude of the carrier wave. So this mu is also called as the M. I have used the symbol M. We can also use mu or M, both are same here. So three possibilities are there when M is equal to 1. So M is equal to 1 and here M is greater than 1 and here M is smaller than 1 or greater than 0. So these three possibilities are there. When Vm is greater than equal to Vc, or Vm is less than Vc, or Vm is equal to Vc. So three possibilities are there and three figures we can obtain with the help of this. So we can also draw this like this is our diagram. So we have plot this and this figure is for when Vm is less than Vc. For Vm less than Vc, we have plotted this. Now expression for the AM wave. So here we have used this MT is our message signal. Like that signal, the signal that we want to transmit. Or we can also use the expression like in this way. Vt is equal to Vm sine omega mt. And for carrier wave is high frequency wave. So we can also use this in the form of like VCT and this one was the VMT. So this is VC sine omega CT. Here we have used in the form of cos or we can also use in the form of sine also. So this one was message signal in form of cos. This one is the message signal in form of sine. This one is the carrier signal in form of cos and this is the carrier signal in form of sine. And after that AM modulated wave we have seen like in this way. This is the AM modulated wave. So amplitude of this wave we can see this much is Vc and this much is Vm sine omega mt. So for writing the expression we can use Vam is equal to Vam sine omega Ct, because in this AM wave frequency will be same as the frequency of the carrier wave. So we have written Vm, small Vm indicates the amplitude modulated wave, capital Vm indicates the amplitude of the amplitude modulated wave, sine omega Ct is the frequency of the amplitude modulated wave. Now this capital Vam is the amplitude of the modulated wave and it will be equal to Vc plus Vm sine omega mt. So we can write this expression as Vam is equal to Vc plus Vm sine omega mt and sine omega Ct. So this is the expression for the AM wave and we have obtained this expression as a AM wave. Here we have used the cos values and here we have used the sine values. So both answers are correct because sine wave in the form of cos also. Okay, so this is the expression for the amplitude modulated wave. This amplitude modulated wave, it transmits the signal from the transmitter antenna. Using antenna we can transmit these signals over the channel. Now we have obtained that expression, and here also we can also reduce that expression in another form, like we have obtained that expression like VAM is equal to VC plus VM sin omega mt plus sin omega ct. So I can write, we have studied that M is equal to Vm by Vc. So we can write Vm is equal to MVc. So here we can write this Vm is equal to Vc plus MVc sin omega mt multiplied by sin omega ct. So this will be Vc plus, sorry, this will be equal to Vc sin omega ct plus MVc sin omega mt sin omega ct. So this is the final expression, and here we can see Vc sin omega ct. It represents the carrier wave, and this MVc sin omega mt sin omega ct, we can apply the formula sin A sin B to sin A sin B. So sin A sin B will be equal to cos A minus B by 2 minus cos A plus B by 2. So we can change this expression in the form like this will be converted into Vc sin omega ct plus MVc by 2 cos omega c minus omega m t minus MVc by 2 cos omega c plus omega m t. So this expression has been converted into this form. We have used the formula of sin A sin B, and so here we can see this is the expression for the carrier wave, and this is the LSB lower sideband, and this is the upper sideband USB. So this is the expression for the AM wave that we will transmit through the antenna. So this wave will contain the carrier wave and the lower sideband and the upper sideband. But in this way, in this equation, the message information is only in the sidebands, because this is the carrier wave. It does not contain any information or the message. Only messages are in the sidebands. Okay, so here now the derivation of the modulation index is there, and this derivation we will discuss in the next lecture. Thank you.